We are going to talk just briefly today about complex numbers. It's the last kind of new thing you'll learn while I'm out. And we're going to talk about two parts of them. So complex numbers are something you have not seen before. They are essentially a combination of real numbers and imaginary numbers. So we call them complex because they have two parts. And we're going to define it in a little more clarity and then also do some simple operations with those. So let's hop right in. The definition of a complex number is a number of the form A, where A is a real number. It's called the real part. And we add that to some number B times I, where BI is the imaginary part. So essentially we have half of our number is a real number, like 2 or 6 or 100. And the other half of our number is an imaginary number, like plus I or minus 7I or plus a third I. So down here I've got three examples. Our first is 5 minus 3I. The real part here, our A is 5. And the B, which is the real part of our imaginary, so the coefficient in our imaginary number, B is equal to negative 3. This second example, negative 17 plus I, we've got an A here of negative 17. It's this number over here, our real part. And our imaginary part is I, which means our B is just positive 1. And our last example is a little messier. It's 1/2 minus I root 2. This over here, this 1/2 is our real part. So our A value is the fraction 1/2. And over here, we've got I root 2, negative I root 2, I should say. So this is our imaginary part, but our B value is that negative root 2 that is multiplied by that I. So complex numbers, again, are a real number and an imaginary number. They always are of the form A plus BI, so they have to have an I in them, and they have to have a constant. We're going to learn how to add or subtract and multiply these today. We are not going to learn how to divide. Division comes later. So let's go down and look at these two examples. So addition subtraction works just like you expect it to. And the main rule here is that we add like terms. We add our like terms, which means real gets added to real and imaginary gets added to imaginary. So our example is 4 minus 2I plus 3 minus 6I. And how we do this is we identify the real pieces of our question, 4 and 3. And I'll write those over here. We get 4 plus 3 as our real pieces. And then we identify our imaginary pieces, negative 2I and negative 6I. Now I'm choosing to write out to rearrange using my properties of real numbers to rearrange my terms in order, but you don't have to do that. All we're really doing is adding 4 plus 3 to get 7 is the real part of our answer. And I'm going to add my imaginary parts, negative 2I minus 6I, and get negative 8I. And so our answer is kind of what you expect given that we've added with variables before. We're just adding our like terms, 7 minus 8I. Multiplication also works very similar to what you'd expect. I kind of think about treating I like x, like a variable, until the very end. And so our rule here is we're going to distribute as normal. We'll distribute as normal, and then the only thing that changes is we have to simplify any terms that have an I squared in them. Remember that I squared equals negative 1. That's that definition of the imaginary number that we learned, and we're going to need that to finish our multiplication. So I'm going to do this one by just distributing normally, and then I'll do a second video with a couple more examples if you want them where I'll use the box method. But I'm going to start by taking this 4 and distributing it to the 3 and to the 7I, and I get 4 times 3 is 12. And 4 times 7I is plus 28I. And then I'm going to also distribute on the other side the negative 2I to 3 and the negative 2I to positive 7I. So negative 2i times 3 is minus 6i. And negative 2i times 7i is minus 14. And I have I times I, so I get 14i squared. Now, when I go through to simplify this, one thing I want to think about is that I will have real and imaginary numbers, so I have to make sure I'm just combining my like terms. So I'm going to start working through here. I've got 12, and then I've got 28i and negative 6i, and those will combine to give me plus 22i, and then I can bring down that negative 14i squared. So now I've combined all my like terms, except I haven't simplified my I squared. So I've got this I squared over here that I need to deal with. And so I'm going to rewrite this again as 12 plus 22i. And instead of negative 14 times I squared, I've got negative 14. And instead of I squared, I'll replace it with negative 1 because I squared equals negative 1. And if I keep simplifying, this is 12 plus 22i, and this becomes a plus 14 because a negative times a negative is a positive. And now at the end, I can take my real pieces, my 12 and my 14, combine those like terms, and I get 26 plus 22i. So it should work just the same as normal distribution, but you're almost always going to end up with this term over here that you need to deal with because it has this I squared in it, and we know I squared equals negative 1. So I did this in lots of steps. You might have done this in 2 or 3 steps on your paper because you simplified that I squared earlier, or you didn't do each step individually. That's fine with me as long as you're getting to this answer at the bottom. So if this is all you need, go forth and start your practice problems. They're all going to be either these addition or multiplication problems, but I'll add a second video if you want to see 3 more examples of this multiplication. All right, best of luck.